Good afternoon, class 10th. I hope all of you have done your homework of your previous classes. So today we will continue on with types of reactions, and before that I'll be giving you two questions, your in-text NCERT questions to write in your copy. You can pause the video and write the questions. First question is, a solution of substance X is used for whitewashing. Name the substance X and write its formula, and write the reaction of the substance X named in above with water. So the X is calcium oxide used for whitewashing. That is your quicklime. Okay, that is CaO. As well as the reaction is, of course, you have done the reaction of quicklime and water. CaO plus H2O gives CaOH whole twice. Calcium hydroxide is produced, that is slaked lime. Chuna. You can pause if you're still writing. Why is the amount of gas collected in one of the test tubes in activity 1.7 double the amount collected in the other? Name the gas. So in that activity, you have seen that hydrogen and oxygen were being evolved. So water contains 2 hydrogens and 1 oxygen. Okay. So when the ratio is produced, if you remember the balanced equation, right, it was 2H2 plus O2 was giving you H2O, and then H2O was breaking down to give you 2H2 plus 1 O2. So 2 hydrogen, double the amount of hydrogen is produced than oxygen. For every 1 molecule of oxygen produced, 2 molecules of hydrogen were being produced. That is why 1 ratio was double. So the 2:1 ratio, it is of hydrogen and oxygen. Okay. Okay. Good afternoon, class 10th. I hope all of you are doing well. So we will continue from where we left off. I hope you did all the questions that I've given you in the beginning of the video. So we'll start off with the third type of reaction. The first two we did were combination and decomposition. Alright. Now we will look at a new type of reaction, that is displacement reactions. You are hearing this word for the first time. So there is an activity 1.9 in NCERT. Open it up. Don't worry about missing out on these activities. We'll find the time to do it once school reopens. Okay. But right now, try and read them and understand what's happening in the activity. So, in short, I'll tell you what we do. We take a test tube. Now, in it, we take blue copper sulfate solution. Blue copper sulfate. Copper sulfate formula CuSO4. Okay, we take blue copper sulfate solution, and in this solution we put a iron nail. We just simply place an iron nail in it, we submerge it. Okay, now what happens is, after some time you will notice, I'll draw a second one. This is after some time. You will notice that the solution has now become green in color. And there is a reddish brown precipitate on the iron. Okay? A reddish brown precipitate on the iron. What has happened is, if you remember, what was iron? Iron was Fe. So now iron is a metal that is more reactive than copper. Okay? Iron is more reactive than copper. So what happened is, in the solution there were copper sulfate. So copper sulfate in solution, there was Cu2 plus and SO4 2 minus. They were existing in solution, they were existing as ions. Okay, so in solution, always whenever you write an aqueous solution, they exist as ions. So copper sulfate exists like this, okay, as ions. So now this iron reacted with this solution, and what happened was, if you have understood this, I'll be rubbing this. First one. Now the iron reacted with copper sulfate to give you Fe plus CuSO4 gives Cu from here got removed and Fe came here. So now we got iron sulfate. Formula of iron sulfate is FeSO4. And Cu as a metal removed out. So what you see here, this reddish brown precipitate around the iron nail, that is your copper. That is your copper. And the green solution is FeSO4 because FeSO4 is green in color. Okay. So now the green solution is FeSO4. So what happened here? This single element iron displaced Cu. It removed copper from here and took its place. So it became FeSO4. Right? So this reaction is called a displacement reaction because one element is displacing another from its compound. So basically in a displacement reaction, what happens is any A, this A was your iron, okay, a single element A reacts with another compound, that is, let's say C and D. Now A replaces the C. A will always be generally the cation. Okay, so the cation replaces C and we get a new compound AD and we get C separately alone. Okay, so A plus CD gives AD plus C. This you have to write down for displacement. First thing that you will write down. Okay, now write down the definition along with this. Those reactions in which, I'll write it down for you, those reactions in which one element, takes the place of another element, in a compound. You have to write this correctly. Element in a compound is known as displacement reactions or are known as displacement reactions. Okay. So what happens is one element, this was your iron, write the definition in your copy. Okay. This was your iron, displaced another element in a compound, that was copper sulfate. So copper sulfate was your compound. It displaced copper from its place and it became iron sulfate and you got copper separately. So that is why displacement reactions. Okay, let's look at more examples of displacement reaction. Copper is very less reactive, so most metals react with it and displace it. Okay, so let us look at the next example. CuSO4 plus Mg. This is magnesium. This is your copper sulfate. Mg is magnesium. You get Mg. Mg charge is also 2 plus. SO4 2 minus. So MgSO4. This is again magnesium sulfate. Magnesium sulfate plus copper. Another example of displacement reaction. Similarly, let's look at more examples. CuCl2 plus Pb. What is Pb? Pb is lead. This is copper chloride. Copper chloride. Now these two react to give Pb, again cation Pb2 plus, so PbCl2 plus copper. Okay, you should know how to write all of these. This is lead chloride. Lead chloride. Also keep on writing the states also. The compound is in the aqueous state. This is in solid state. Now this becomes in aqueous state and this becomes in solid state. Make sure you write the states for all the reactions, okay? So lead is also displacing copper. Let's look at more examples. Now there is a metal that is even less reactive than copper, and that is your silver. So AgNO3. This is silver nitrate. Ag plus and NO3 minus, so 1 1 each. Silver nitrate. You should know how to write the formulas of these compounds. AgNO3, this is in aqueous, plus copper will give you copper nitrate. What will be the formula of copper nitrate? Quickly I'll show you here. See, Cu2 plus and NO3 minus. So when you cross multiply, you will get CuNO3 whole twice. So you should know how to write this. If you can't write this, your balancing will go wrong. Okay, so make sure you know how to write this. So you will get copper nitrate plus Ag as a metal separately. Now this is existing in aqueous state and this is in solid state. Is the equation now balanced here? No, it's not. We have NO3 1 ion here and 2 NO3 ions here. So we'll have to make this 2. Yes. And now we made that 2. We have to make Ag also 2. Now the equation is balanced. Okay. So this is your balanced equation. Let's take it. Look at more examples. Fe plus HCl gives iron plus hydrogen chloride. This HCl is also known as hydrochloric acid. Okay, so this is solid. Again, this is in aqueous. So what will we get? Iron chloride. Now what will be the formula of iron chloride? FeCl2 plus hydrogen. Now you get hydrogen. So what was displaced this time? Hydrogen was being displaced. So it's evolved in the form of a gas. If the metal is displaced, it will become a solid. If the gas is displaced, then it will become a gas. And this is in aqueous state. Okay. So you can look at more examples which you will find in your book also. A lot of examples for displacement reaction. Okay. One last one we'll do. Fe2O3. This is your iron oxide. Here it's iron is existing in 3 states. So iron 3 oxide. That is, it's Fe3 plus and O2 minus. Okay. It's the 3 plus wala cation here. You should know that. In iron oxide, it's existing as 3 plus. So you have Fe2O3. Okay. Next, it's reacting with aluminium. That is your solid. It gives you aluminium oxide. Formula Al2O3 plus. Last what is left? Fe. Okay. So now we have to again balance it. Fe is a solid. Al2O3 is also a solid. Here you actually get a molten state of iron. So it's not solid. You get iron as liquid. This reaction happens under a very high temperature. So you get a molten state of Fe. So that exists as pure liquid. Okay. And aluminium oxide exists as solid. This is an important example which you can study. Fe2O3 was your solid here. And your aluminium was also a solid here. Okay. This reaction happens under very high temperature. And that is why you see a molten state of iron. So in this reaction now, again we have to balance this. Is this balanced? No. So let's see first. Al2O3. Will I start from here? O is 3, O is 3. Okay. Al2, 2. So we need to add 2 here. Then this is fixed. Alright. Now let us look at this. Fe2O3. Fe is 2 here. 2. So 2. Now it's balanced. Okay. One more thing. You have all learned about cations and anions. But when metals are existing in their pure state, like if I write Fe solid, the charge of this is 0. Okay. You should know that. Just in case. So this was your displacement reaction. I hope all of you understood this displacement reaction. Now we will move on to another type of displacement reaction. This is your fourth type of reaction, very important, and that is your, this is your fourth type, okay? Double displacement reactions. Write down the heading, double displacement reaction. So from the name, what do you guess? What is happening here? Two displacements are happening together, okay? So doubly it's getting displaced. So two displacements are happening together simultaneously, okay? So let's see what is happening here. In double displacement reaction, you have one AB, you react it with another CD, and what happens is this cation will replace C like in displacement, and similarly this will react with D. Okay, so what happens is this C and A will interchange. Basically, these two cations will interchange. Just interchange that. So you will get something of the sort CB plus AD. Okay? The cations will interchange their positions. So this is what you will get as your product. Write down this. AB plus CD will give you simply AD plus BC. So these two will interchange. The cations basically interchange their positions. So let us look at some examples. Okay, now while studying displacement reaction, you'll have to look at one more thing. So we will start off with the first reaction, that is sodium sulfate. Na2SO4, sodium sulfate. Why is it Na2? Na plus SO4 2 minus, you cross multiply, you will get Na2 and SO4 1. Okay, so you cross multiply these numbers and you will get them. So you should know the cations and anions to write the correct formulas, because in the question sodium sulfate will be given to you. The formula most often than not will not be given to you. So if it's not given, you should know how to write it. Now we react sodium sulfate with barium chloride. Barium chloride again, Ba2 plus and Cl minus, cross multiply, you will get BaCl2. This is your barium chloride. Now mostly you will see in double displacement reaction, both the reactants are in aqueous state. So this is also in aqueous state and this is also in aqueous state. They react to give you, now what was I saying? The cations will replace each other. So Na will come here and Ba will come here. So what should you get? Barium sulfate, just sodium chloride and barium sulfate. Okay, this is an easy way to remember double displacement. Sodium chloride will become and barium will become sulfate. So what you will get finally? You will get BaSO4 plus sodium chloride is your NaCl. Now you should know the formulas. Simply you cannot put Na2Cl2. No, that will become wrong. You have to know sodium chloride is NaCl. Similarly, you have to know barium sulfate is BaSO4. So when you form the compound, look at your cations and anions and form the compound. Don't just randomly substitute the numbers also. Be careful about that. So this is your now barium sulfate and sodium chloride. Okay, so this is your reaction. Now, sodium chloride here is in aqueous state. The barium sulfate now has become a solid. When this reaction happens, what happens is this barium sulfate becomes a salt-like solid and it will settle down completely. So the term that we studied earlier, you might have heard of this term before also in the earlier classes. The term was precipitate. So here, like you studied a lot of types of reactions like exothermic and endothermic, etc. This is not a type of a reaction. This comes under double displacement, but it's not a type of reaction. The 5 main types this does not come. We are still doing the 4th type. We are called, these kind of reactions in which you find a soluble white PPT are called precipitation reactions. Precipitation reactions. Okay. Now, again, I'm telling you precipitation reactions does not come under the main 5. What all have we studied in the main 5? The main 5 was combination, decomposition, displacement, double displacement, and we will study the 5th one also. But this does not come under that type, precipitation. Okay. So what is precipitation reaction? Precipitation reaction is any reaction. Write down the definition. Write it down as a term and you write down the definition. That produces a precipitate as a product. Produces a precipitate as a product is called precipitation reaction. Okay. So as a precipitate as a product is called precipitation reaction. So we'll take a look at more examples, and wherever precipitation is taking place, we'll mark that also. Okay. So let us take a look at more examples of precipitation. First one, silver nitrate. AgNO3, we did it before also. This is silver nitrate. Again, this is existing as aqueous plus sodium chloride, NaCl. Now, your NaCl was your, again in aqueous state, sodium chloride. This reacts to give you, now again Ag will react with now Cl, the cation and the anion. Cation is on the left, so cation and the anion. So it will become silver chloride. Silver and chloride. Sodium and nitrate. So you will get silver chloride. The formula of silver chloride is AgCl. Ag plus and Cl minus. And this is your solid. The silver chloride formed is your solid. This is your precipitate. So you can write solid or you can also write PPT. Okay. Both are correct. Plus sodium nitrate, NaNO3. Sodium nitrate. This is in your aqueous state. Okay. So this is sodium nitrate. And this is silver chloride. Make sure you're writing the names also, not just the equations. Okay. Let's take a look at the next example. Barium chloride, BaCl2 aqueous, this is barium chloride plus copper sulfate, CuSO4. Barium chloride, copper sulfate. Now again they will react. What will you get? Barium sulfate, and you will get copper chloride. So you got barium sulfate plus copper chloride, CuCl2, Cu2 plus and Cl minus, so CuCl2, copper chloride. So now copper chloride is existing as aqueous solution and barium sulfate is existing as the solid PPT. So this reaction is also an example of precipitation. So these three reactions that you have done, if the question comes what is precipitation reaction, you can write the definition and you can give these examples, any of them, in which you have to show which is the PPT. So this will be the precipitate. Okay. So we are doing two types of reactions at once. Double displacement, and mostly double displacement reactions are also precipitation reactions. Now let's take a look at a gas one. Copper sulfate existing as aqueous form when you react it with hydrogen sulfide. Hydrogen sulfide is a gas. Okay, so we pass the gas through the solution through a pipe, and what do we get? We get copper sulfide, CuS, plus you get hydrogen sulfate or sulfuric acid. So you get H2SO4. Again H2SO4 because H is plus 1, SO4 is 2 minus. So when you do that, it will become H2SO4. So this is copper sulfide, this is hydrogen sulfide, and this one is copper sulfide. You write the names also along with them. Make sure you get into the habit of writing the names. And this is copper sulfate. Okay. Now is the equation balanced? Yes, it is completely balanced. Okay. Let's look at another one. One last example we'll do now. Then we'll do more examples and when we do the questions. Okay. In the question bank, I'll give you more and more examples. One more example. Aluminium chloride. Aluminium chloride plus you react it with ammonium hydroxide. Ammonium ion is NH4 and hydroxide is OH. So ammonium hydroxide. Both are in aqueous states. Aqueous and aqueous. Now you react it. What will you get? Aluminium hydroxide and ammonium chloride. So you will get aluminium hydroxide. Again, formula is Al is 3 plus and OH is minus 1. So AlOH whole thrice. Hydroxide ion will come 3 times. This is your aluminium hydroxide. Okay. Now what else? Next one is ammonium chloride, NH4 and Cl. NH4 is plus 1, Cl is minus 1. So both are 1. So NH4, Cl, this is your ammonium chloride. Is the reaction balanced? Ammonium chloride. This is your PPT and this is in your aqueous state. Is the reaction balanced? Let's see. NH4OH. NH4, NH4. OH is 3 here. So we have 3 OH here. Okay. Again, let's take a look at it. Ammonium chloride. Cl is 3 here. Here it's only 1. So what do we have to do? We have to balance this. So how do we go about balancing this? We have to make 3 Cl. So let's put 3 here. 3 NH4. So we have to give 3 NH4. 3 OH and 3 OH. So now the reaction is balanced. Okay. So this is your balanced reaction. You have to increase here. That's done. One last very common example of displacement, the most famous one, which you will be studying further in chapters also, is your simple displacement, easiest one to remember, NaOH plus HCl will give you NaCl plus water. Okay, NaOH is aqueous, HCl is aqueous. This is a base and this is a acid. That's why this reaction is very famous. So you can remember it. This is your sodium hydroxide. You'll study it in the next chapter. Reaction of acid and a base. Sodium hydroxide, and this is your hydrogen chloride. This is your sodium chloride. What is sodium chloride? Common salt. Okay. Common salt formula is sodium chloride. The salt you have at home. The main constituent is sodium chloride plus H2O liquid. So sodium chloride is your PPT, the salt that comes down. This is your final example that you will study about double displacement reaction. So I hope you've understood the difference between displacement and double displacement. One more time we can go through. Okay. And that is, difference is, in displacement one element was replacing the other. That's it. That was displacement. Okay. But in double displacement, 2 displacements were happening. That is why double displacement, right? So you were getting AB plus CD A was going here, A and C interchanging, both C was replacing A and A was replacing C. Both was happening. So we got C and B plus A and D. Okay, so this was the major difference. In displacement, only one displacement is happening. In double displacement, two displacements is happening. And generally, one of those is a precipitate. Okay, so now we'll move on to the last and final type of reaction. You can write the heading and you can leave it. We will do it in the next class. Oxidation and reduction. I hope you are finding this interesting because it is very important and new also. So that's it for today. We'll go to the next topic in the next class. So take care. We'll meet tomorrow. Bye.